Okay, welcome to the beginning of this sequence tutorial on principal component analysis. This notebook is sort of a meta topic where I am showing you why you should not drop out of NumPy or Numpy. I will say both. You'll hear me say both. So first we're going to load the libraries that we need. Now, just to review, there are two different data types in Python when we're talking about arrays. There's the list and there's the NumPy array. And the point here is that if you're working in NumPy, you don't want to change your objects back into lists. So the most common way that you can do this is via a list comprehension. So you see here, I've got a NumPy array 1, 2, and I use a list comprehension, which seems like a good idea. List comprehensions are great. But in doing this, I've actually changed the NumPy array back into a list, and this is bad. So one way you might be tempted to do this is by loading in the Python math library. So here we're going to use this Python math library, and we're going to use it to attempt to create a vector of cosine values for a sequence of values. So we've got VV here is a linspace from 1 to 1,000 values. And we want the cosine of each value. We want a new vector that is the cosine of each value. And we're going to try to use the math.cos function to create this vector. And you can see that it actually throws an error. We cannot pass a vector into the math.cos. It can only take scalar values. So this is already a problem. We're going to be able to just use np.cos to calculate the cosine of the whole vector. But you might say, what about a list comprehension? So here we go. Let's calculate this using a list comprehension. So the cosine of VV is going to be equal to math.cos of V for V in VV. So we're going to take the cosine of each value each value in this vector of values. And it works just fine. The issue is time. So here I'm just going to do np.cos to create that vector. And I'm going to do the same thing with a list comprehension. And while we're discussing this, I'm just going to go ahead and run the rest of those because it's going to take a moment for those to run. So you can see that in creating the vector of cosine values using the math.cos, it actually took about almost 10 times longer to run. So this is why we want to stay in NumPy. We're going to be optimized for speed here. And as we scale up, it just gets worse. So 468 nanoseconds versus 2.4 microseconds. In general, it's a bad thing to do. So the moral of the story here is don't drop out of NumPy.